Okay, let's do some more on radical simplification. If you look at this first example, the cube root of 6 times the square root of 2, the unwritten index here is a 2. Notice that the indexes are different, so this problem cannot be simplified. And it cannot be simplified because the indexes are different. Okay, let's move on to this guy. Notice my indexes are the same. So I can put everything underneath, and my negative sign, I'm going to call that a negative 1. And then my 4, I'm going to break down into a 2 times 2, and then I'm going to bring this 2 underneath my radical, and this says you're looking for groups of 3. Well, here's a group of 3, so they're all going to come out as a 2. And then the cube root of negative 1 is a negative. Now the even root, if this was a 2, of negative 1 would get us into the subject of imaginary numbers, and that's not what we're doing. We're doing everything as real numbers only. Right, let's move on to another example. The square root of 12 plus the square root of 75 minus the square root of 3. Well, everybody has the same index, so that's good, but I cannot work with these the way they are because they are not like radicals, so we need to begin by simplifying. So if I take my 12 and I call that 2 times 2 times 3, breaking it into primes like we've done before, and I take my 75 and I say that's going to be 3 times 5 times 5, and then there's no simplification to do with this one, taking out groups of 2. Alright, so that's going to come out as a 2 times the square root of 3, and these are going to come out as a 5 square root of 3, and then again, no simplification, but it still needs to come along. Notice that my radicands, square root of 3, square root of 3, square root of 3 are alike. Now if you want to think of this way, we do have a 1 in front of here, so we can combine our coefficients. 2 plus 5, 7, 7 minus 1, 6, 6 square root of 3. Now if you wanted to check your answer using your calculator, you could put this original problem in and get a decimal, and put in your answer and get a decimal, and your decimals should match. If they don't match, you better go back and check your simplification because something has not gone well.